Hello, and welcome to another fully live and slate episode of Hacking with Friends. My name is Kody Kinzie, and today we're going to do a live stream with my good friend and hardware hacker, Arya. Arya, thank you for joining us today.
Hi.
So we have been friends for a good amount of time now, ever since you and I met at the Hackaday SuperCon. Like when? What in like 20? Was it like 2018 or something like that far
Yep.
back?
Yep.
Wow. Yeah, so that was in
Yeah.
Pasadena, California, and it was funny because when we met, I thought we were meeting for the first time, but it actually turns out that you had worked on this awesome project called the ZeroPhone that I had been obsessed with for a while, and we'd actually
Oh,
communicated
all right. All right.
through like
Yes.
Hackaday messages, like a year before, because we were each working on projects that we thought were cool. So
Yeah. And I also followed some of your projects on Hackaday, the photography parts and.
yeah, it was really
Yeah.
cool to find out that we'd secretly been talking in the background for like a like a little bit even before we met in person. So, if
Yep.
you haven't seen any of Arya's work, she is a pretty prolific like hardware hacker. She's worked on a number of different projects that I found. Like I said, the ZeroPhone was one that I initially found just super awesome, and that drew my attention because I'd never seen anyone do something like that before. But you actually support yourself mostly on making your own hardware designs and selling them. And that is a big dream of a lot of people who are getting into hardware or who are making hardware for the first time to, want to be able to make stuff that people want enough that you're able to like sell it to make a living. And it's definitely something that takes a lot of energy, but it's really cool that you've done that. And I think a lot of people in our stream would probably be curious to know how you got into kind of creating your own hardware and why people find it so useful.
Yeah. That's a whole story, and like I'm slowly going towards teaching people how to get into the same field, how to sell their own hardware, because there is so many things that so many different people develop, but it tends to stay in GitHub repositories the best. And hardware should be shared. That's kind of my belief, and I'm working on getting that into minds of people on how to actually how to actually bring things into reality, because it's way better when it's hardware that you can actually work with. I just adore that aspect. And yeah, you'll definitely hear about that. Also, apparently Hackaday Mastodon server is down.
Oh no.
I'll poke them. Yeah.
Yeah, I know there's
Happens.
also a lot of people in the Hackaday community that might have already heard of your project. In fact, somebody in our audience, let me pin this, says ZeroPhone, is that the Raspberry Pi phone project, right? I've seen that. Yeah, that was a pretty famous project. Can you explain like a little bit about what
Yeah.
that was or how people might have heard of it?
uh it was all over the place in like 2017. It uh it's it was a stacked PCB design. It's basically an open source mobile phone that you could build yourself, and it's running Linux, Python powered. And I put a lot of effort into self-assembly aspect of it, so it was a kind of educational tool and also hacker tool that I personally always wanted to see,
Hmm.
and nobody was doing for some reason. And the I was working on it for quite some time. I was trying to get into production, burned out on it, and yeah, it's currently in the back burner. But people say like every now and then that it impacted them into like one aspect or the other. So it's been a good project.
I think it's introduced a lot of people who have like looked at a Raspberry Pi and been like, okay, it's cool that I can do, these really easy projects, but what's the craziest stuff I
Hmm.
could do with it? Like I think that
Yeah.
you had one of the projects that was like really far out there for like what the furthest reach of that device is capable of, but still like kept it within the bounds of reality. Because the typical like Hackaday project is like something that's like wild and crazy, but like there's not even a prototype. It's just like a design that's like kind of going towards something, in the future that's very aspirational. Like you have, I think, a talent for being able to like do a minimum viable product that people think is cool because it actually, it works. It might not be as far as you want it to go, but like I think that you keep things very practical when you like pick a topic or when you're like making a design. you know,
Yeah,
kind of
that was
avoided the
such a
typical.
balance to keep. Yeah, that was exactly where I was trying to get, because like educational stuff is my passion, and I was specifically trying to get in to the point where a person realistically could assemble it, and quite a few people have, uh, like not hundreds, but maybe a dozen at least that I've seen. Oh,
Hmm. So another thing that I also wanted to shout out was you are directly responsible for the, we're calling it the Meow Mixer now, is the
yes.
tentative name of this PCB, but you were pretty much
Mm-hmm.
directly responsible for making sure that this worked when it got to us by double checking the design and making sure that all little like fine details were taken care of. When you're making a PCB design, like having a design check or a design review is really super important. Um, yeah, I just for one, I would just want to shout you out and thank you for that. Being able to like catch small little things that you just don't notice when you're like all deep in the design is like so important. And you did a fantastic job with that. For beginners who are struggling with like mistakes in their PCBs or like maybe like missing things because they're so new, like, do you have any advice to them on like either getting a design review or like being able to like catch little mistakes that might trip up your first design?
Get out there and talk to people is my advice. There is Adafruit's Discord server. There is a lot of small community Discord servers where, and also the Hackaday Discord server, which is kind of a secret link that we put into an articles every now and then. But if you look for Google for Hackaday Discord server, you will find that. It's yeah, it's kind of in a bit in the dark kind of thing, but it's an official one, yes. Uh, and if you go to some Discord server and you post pictures of your board, of your schematic, if you can upload the KiCod files, for instance, people will most likely be happy to give you advice. And there's quite a bit, like every now and then, that happens in Hackaday server. I haven't been much on Adafruit, but I'm pretty sure you will find a channel or two there as well. And I can highly, highly recommend doing that, because it just saves so much time and energy and money when you can make sure that your first revision works. And I give design review to people. I know there is other people that just hang out in communities and do give design review. You should seek it out,
Hmm.
and usually it's at an arm's reach. So
So up on the
yes.
screen, I have the Adafruit Discord server, which I actually am already a part of. The Adafruit Discord
Mm-hmm.
server actually has a specific channel, Help with Hardware Design. And I can see people in here as of yesterday, like giving advice to other people who are working on hardware designs, like showing them with like hand-drawn diagrams, like the correct way to do something and like reviewing schematics. So if you're someone who's interested in hardware, you want to make like a simple PCB, but you're worried you're going to make a mistake that like wastes your money and your time, like there are communities out there like, you know, the one I'm looking at right now that seem to be willing to give you like free advice on your designs, on your circuits, like on your like schematics. Like, so if you're somebody who's interested in doing hardware, but you don't have like a circle of people around you, like you don't have people locally who do hardware, that can be kind of intimidating. And I don't. The only PCB factories out in my area make like glide bombs for the military, and they're not like very, you know, they don't really do anything else. So getting in touch with people remotely who are working on these sorts of designs is a really, really good idea, because like I said, we had a super talented person work on this PCB design and it was ready to go, and Arya took a look at it and found out that it wouldn't have worked as designed because it was missing a certain grounding point where like the circuit wasn't, basically hadn't been completed all the way. And there were some warning signs here, but
Mm-hmm.
somebody who wasn't looking for them might not have been able to catch that. And the people in these
Mm-hmm.
Discord communities are often really, really good at that because they're seasoned professionals. And if it's something surface level, if it's something relatively easy, they can often spot it really fast. Like you can see here, um, I just really love and appreciate these like these hand drawn on like screenshots, you know, that are like trying to like teach other
Mm-hmm.
people in the channel. So yeah, I think that that's really great advice. And here's like a example like on your screen right now of people getting free PCB design advice for making their first PCB. So if you've been thinking about it, if you've been wanting to do it, like this is a good way to get started. Like these communities will help encourage you and maybe even give you some inspiration by seeing what other people are getting. So also somebody in our server, in our chat is asking, where can they buy your work?
Yeah, also, sorry, I would be answering things in the chat, but I just don't have my YouTube account logged in right now. It's right there. There's a Tindy link. So I have quite a few things that people have been statistically interested in on my store.
I'm gonna click on it
Tindy,
and bring it up.
Tindy is a wonderful platform. I can highly recommend just if you have something that you feel like other people could use, just consider listing it there. Selling things might be easier than you imagine, and Tindy makes it all that way more easier. Like you do have to ship things, you do have to assemble things, but you figure it out, and you can just get money for things that you would have been doing like anyway. So
I like that.
like,
So I'm looking at some of these projects, and for the casual user, like a lot of your stuff is like highly specific to like a certain application where like for like, like 30 people on Earth, they're like, this is exactly what I need. But other your projects are like much more general. Like some of these look really cool, like the true read-only micro SD card. What do you think of your projects would be the most interesting to like, somebody who's like a little bit of a novice but is interested in hardware?
I think that would be the alt mode friend, which I have to produce more dev boards for that one. But you can start playing with USB-C, and that I find quite impressive.
All right. I just pulled it up.
That part is this device is like letting you communicate USB-C, which is like not such a well-developed field in hacker culture, even though it has quite a bit of potential. So, for example, you can get variable voltages out of USB-C power bricks. You could get like DisplayPort or USB. You can basically build your own USB-C peripherals of more or less any complexity. And this is also a product hot on the heels of my series of articles about USB-C, where I go through like different aspects of USB-C. I explain it because, well, people should be hacking on it, and now there's maybe not nearly enough people hacking on it. And this is just like if you want to take a field and you want to have some experiments with it. For example, you can figure out that there is documentation for how to charge lithium-ion packs with just a USB-C power supply. So you don't have to have like a bulky box, and maybe you can just figure out how to make the USB-C power supply charge your battery pack, because a lot of modern USB-C power supplies have the technology which is called PPS that's specifically very suitable for battery charging. But nobody takes advantage of that. And that's a bit painful for me. And I would like for people to have easy to get tools to hack on some parts of, everyday tech like this. And this is just one of the aspects that I'm currently looking in. And maybe you can uncover some very cool things about USB-C if you just get one of these to tinker. For example, possibly you can make a USB-C power supply into an LED driver, or as I said, a battery charger. It's like a small but fascinating field in that regard.
I feel like this sums up a lot of your projects, like something that's like a building block for other people to jump off of, that has like wide applicability and is like super specific, like into the weeds on like a piece of technology that people use all the time, but maybe haven't unlocked the full potential of.
Yes. And this is just one thing. I'm also going to be working on PCI Express peripherals in this, but for now it's just USB-C. Other things in my store are mostly general, yes, sadly.
No, that's so really cool.
Not general, but very, very, very limited.
Oh yeah, it's like the perfect thing for somebody working on a specific type of project. So here's a question that's Wi-Fi related, and I know you deal with all things hardware, probably maybe wireless network adapters a little bit. Oops, sorry, I put up the wrong comment. It is are old Wi-Fi network adapters as effective at new ones? And of course that there's a couple subjective like questions there. One of them is like at doing what? Like if you're talking about like a very simple like process, then maybe it is just fine at connecting to 2.4 gigahertz on like an older, you know, like modulation or whatever. But the new ones are going to be faster for Wi-Fi. They're going to have better range, and for hacking stuff, the ability to switch between various frequencies, like 5 gigahertz and 2.4, is really a must-have if you're going to be like capturing packets or like wanting to capture the whole available Wi-Fi spectrum. Arya, what do you think?
Yeah, absolutely. So I agree with more effective at what, and also Wi-Fi is one of the technologies that constantly keeps improving and improving, and at some point you have to catch up. And also there's definitely like even a new adapter is probably going to be better at dealing with old technologies because there's a better antenna, there's better, more time-tested drivers and firmware, and sometimes an old Wi-Fi adapter, as far as like I did some Wi-Fi hacking like long time ago, and maybe an older adapter is going to be more featureful when it comes to like under the hood features, for example, like it is with ESP8266 and its various like unlocked monitor modes and whatnot. Uh, and sometimes it's like some old cards cards have open source firmware. So if you're looking to build a maximally open computer, then an old card is going to be better for that. But generally, if you can go for the fastest and newest card that you can get, then it usually makes sense to spend a bit more money and go for that.
That's such an interesting exception because, yeah, you're completely right. If you have a card that's a little bit older, but the firmware is open or it's been released or leaked or whatever else, and people have really built on it.
Yes.
Like a good example is, it's not a wireless network adapter, it's a microcontroller, but the ESP8266 is able to do things that the newer ones can't do because the manufacturer locked them down. So for Wi-Fi hacking, it's ironically the older chip that you want on a microcontroller because it's been unlocked to the point that you can basically do things that you cannot do on the newer stuff. So there are a couple exceptions, but yes, Arya is 100% right. In general, you're going to want the newer, faster, stronger one if you're just doing basic stuff. It's only if you have a specific use case where maybe you need access to a certain feature that's been locked down by newer products that you would want to get an older one. But it can be a pretty big, exception, because a lot of some of the juicy stuff you might want to do with Wi-Fi may very well be disabled in some of these commercial, like newer wireless network adapters. We also have another comment. Haha, caught the stream. Give it back. That's my only response. And also your question is definitely welcome. You can ask whatever you want.
Yes.
Okay, so we've got an expert here. So attaching a 6-volt IR with its own power supply to flipper that will control it. Octocoupler, transistor, something else?
What's an IR? I have to ask that. My apologies.
Yeah. Is it like a infrared, or IR blaster, or yes? Please be more specific, because we will answer your hardware questions here. If you've got something a little bit in the weeds, then you can hit us up with it. While we're doing that, also, Arya, did you say that you had a little demo you wanted to show? If you, sorry, an IR. That's an IR LED specifically.
6-volt. Its own power supply. Usually, if it has its own power supply, it has to have some kind of way to control it. Whether it's a button or maybe it's a logic level input, that's what you use, or maybe that's what you hijack and use it and connect the flipper to that, connect it that way. Because unless you have a model number, and if you have a model number, that maybe that's a bit too deep, but also feel free to message me on other platforms about that.
So in general, the problem here is we have a device that runs on 6 volts, and then we have like what's probably a 3.3 volt. Do you know what the flipper runs on? Is it 3.3 or 5?
I would wager it's 3.3.
Me too. Yeah. So
Not
we
sure
have
though.
so we have two different devices. Each one of them is powered, and we want to interface them. Like as like
Mm-hmm.
an electrical person, like we can tell that connecting a 6-volt device to a 3.3 volt device is a bad idea. So there's a number of different options here, and some of which was explained in the chat. So one of them would be if you have like a button, for example, and you're like bridging that, and that is what is
Mm-hmm.
causing the LED to fire, then we could do something
Mm-hmm.
with like a logic level adapter or something like that, or even like James was saying, a transistor that where when we hit it with 3.3 voltage, it completes the button circuit, or it sends a signal that's the correct voltage. So a logic level shifter or translator, which one is the more correct term?
Yeah, that's usually not what you would use for like the things that you would call logic level shifter or translators. Usually not what you would use, but you could absolutely use a transistor which would act then as a logic level translator. Or as James says, I usually always go for an optocoupler if you need to hijack a button. It's just way more easier that way.
Yeah, so for anyone
So
who
yeah,
doesn't know what
indeed.
that is, an optocoupler is a way of keeping two different voltage level or different current level devices separated, even when they're communicating with each other. So typically, it's like a LED, like an infrared LED, and then like an infrared receiver in like a black box, basically, right? Is that correct?
Yep, exactly.
So
And
when this chip gets a signal from one side, it turns on the infrared LED, and then on the other side, it causes a circuit to be connected or something like that, right?
yep, it opens a transistor on the other side. So it's like a remotely controlled transistor that you control with light inside the small little black box. If you disassemble like a laptop power supply or a PC power supply, you're going to see a few optocouplers. They're they're pretty great. They're cool. And
So
the gap, just make sure that you have all that way less chance of burning your MCUs, GPIOs. So whenever there is some danger, I just usually always use an optocoupler to simplify it that way. They're awesome.
that's smart. Yeah, I've broken up open a couple just because I wanted to see what was inside, and it's so cool how simple some of these electronic devices are. Like being able to trigger one device with another is like often not a simple task because you can't just plug them into each other. There has to be an intermediary thing. So yeah, if you're new to hardware, then this is the way that you can solve this problem by using an optocoupler, something that just manages to use light to send a signal instead of electricity. Super cool. All right. We've got some other questions. Whoa, this one's so technical, my guy. All right, we'll try it. I am running Diet Pi, which I don't even know what that is, on a Promox server and have connected via my laptop. I'm trying to paste some script into Diet Pi actually for Docker, but I can't paste it. Is there a way? Arya, I
That's
don't I
such
don't
a
even know a third of the words in this sentence. I'm sorry. I don't know what Diet Pi is. I don't know what a Promox server is. I do know what a
yeah.
laptop is. And I know what Docker is. So I'm so sorry. I'm the wrong specialist for this one. You got a hardware person and a Wi-Fi / OSINT person on the stream today. But next time we have a Docker person, which I've brought a Docker person on before, we could have them on again. They love Docker stuff. They would probably be able to answer this a lot better than I. But still, thank you for your
I
question.
can try. Let me. I don't have a YouTube account, so let me throw that into the private chat.
Sure. Oh, and also speaking of chats, I wanted to give a shout out to our new Discord server. So we've had people asking about making a Discord server for quite some time. And frankly, I want to have a place for people to continue the conversation after the chat and after we shut down the stream. Sometimes people will get the alert late and they'll want to talk about stuff, they'll want to ask questions. So we need the Discord server. YouTube was definitely great for that for a while, but I wanted to just mention that this is now something that I'm going to be maintaining. And making sure it gets regularly updated. So I'm going to invite people via a expiring link on this one because we're just getting it started. I dropped it in the chat earlier. I'll drop it in the chat again. I just want to say thank you to everyone who encouraged us to make this because we've been kind of on the fence about it for a while. And I'm excited to have a place for people to ask their questions for the stream, get support on various projects we've talked about, and also just continue talking after we all log off for the day's stream. All right. Oh, and thank you for the chat, Arya. I just
Yeah, if you can forward that, basically.
sure can do. All right, I'm posting it in the chat. All right, so did you want to do your demo?
Yes, but just to explain the response a bit, that's a HTTP server that you can launch on your laptop or wherever you have the script that you want to run. And on that Pi, you get it or you curl it, you download it from the command line, and then you run it. That's basically the easiest always. Oh yeah, the AI models, yes. And yes, I can do a demo. There's a nugget and there's a wonderful thing called a logic analyzer. And I have a demo that I have this small piece of hardware that streams all the data about what's happening on the Nugget serial port through the USB interface into my laptop. So it's kind of like, in this case, it's sniffing signals from like the UART connection that's happening over this USB cable. And then the signals go just into my laptop directly. And I can show that. Would you mind me sharing my screen? As the entire screen, probably. And now you might have to switch to it. Does it work? It does work. Okay, wonderful. And here I can pick a frequency for the logic analyzer to log the samples and how many samples it's going to log, and then I'm going to only use 2 of the channels because that's the pins on the logic analyzer that I'm using. And now I can press run, and on the nugget I can press the restart button, and as you can see, something's happening. And specifically it's a UART connection that I can just decode. And let me see, I think it goes like this. And it even shows some results. So if you go into, you can see some bytes already that are decoded from the data that the logic analyzer picked up. So it picks up the actual electrical signals on the pins. And that's wonderful when you want to understand what it is actually that's happening in your circuit. And where's the configuration window? Here we go. We can switch to ASCII. And we can see that we're even getting actual characters like 29 point space 3F. So that's a git hash of the compiled firmware.
Could you is there any way to enlarge what you can
password,
see a little bit?
Oh yeah. The text itself is
Yeah, our poor
small.
mobile users.
Thank you. Yes, I'm afraid there's not.
It's okay. I always just try control plus plus plus, and if that doesn't work, I just give up.
Yep, same here.
Sad.
Doesn't work. But well, yeah, specifically for this text, but here you can see that might not be able to see, but it does show you ASCII characters that it picked up over the wire.
So if somebody is doing USB hacking, like this is a way for them to, when a device first starts up, analyze the signals that are being sent to the host computer and probably like being sent back and like figure out what the exchange looks like and what the device is saying to the computer, like how it's setting itself up.
Yep. And specifically for connections like UART, for SPI, for I2C, you can figure out quite a lot of these when you want to see what's actually happening. For example, how is your microcontroller actually communicating to the sensor? And whether maybe there's some problem floating up there. And if we close this one, there's something that I have been working on. So that's a GUI application, but I've been working on bringing that one to the command line. And
this one I know you can make bigger.
You're correct, yes.
Thank you.
Thank you. And I have been working on a script that ties the backend of that GUI tool. So the backend usually looks like this. And there is, of course, there's a lot of data. There's timestamps, there's like hex bytes and such. But if I pipe it into a Python tool that decodes all the transmissions happening, and I press reset, then it's going to decode the actual text that's being transmitted. And the reason I'm doing that is because we've had a problem with flashing the nugget from different browsers, specifically with different tools. So one tool, like the browser tool, would flash the image differently compared to the command line tool. And this exact kind of script and this exact kind of logic analyzer setup is what you need to get to the core of the problem quickly. And yeah, that's why you have like all the color decoding. This is what I'm working on. It's a tool to solve a long-standing and very weird problem that makes the firmware flashing process just all that much more annoying.
So that's such a fascinating problem. So let me just break this down for any like beginners in our audience. Like, so when you're working with hardware and microcontrollers and stuff, you got to flash it with software that's all often running on like a kind of a high level. So you'll like tell a Python program or sometimes even a web browser that you want to flash the chip, and it'll take a program that you've written, compile it, and flash it. But it can do that in different ways because it's usually, again, like kind of high level the way that you're doing it. So when you have a problem, like for some reason, one way, like the browser is flashing one way and the USB script that's just command line is flashing in a different way, and one of them is working, but the other one is not, that is a huge problem for people doing hardware stuff, trying to make sure that it works for the people that are buying this thing and then using it. So whenever we have a mystery like this, the only real way to get it fixed is to figure out what the core problem is and stop using, the very like high level stuff, and instead get very low level and start examining the real difference between like the way it's communicating, for example, or like any subtle differences with the way it's being set up. This is a way to actually do that and get in between the computer and the chip and listen in and see exactly what the exchange is and find out what the problem is or what the difference is when using these two very high level methods of flashing a piece of hardware. Very, very cool, honestly. Like, what is the name of this program, by the way? The GUI that you were using before?
The GUI is PulseView.
PulseView?
And you can see it, PulseView.
That's so cool.
And yeah, and it's fully open source. It works excellently on Windows, on Linux. Sorry, it works less excellently, but still it works on Windows. And yeah, it's been such a huge helper. I've debugged so many problems with it, like just an innumerable amount. I might have invented the word here, but.
Oh, that's so cool. I'm just like looking up an article about PulseView because I had never heard of it, and like I love hardware too, but I have never worked on this low of a level. So that's why we're friends, is because I constantly learn like new ways of problem solving from people who have to solve these problems on a daily basis, where I might only run up against this like once or twice and spend a lot of time scratching my head, like trying to figure out like why it's working two totally different ways when I flash the same chip with the same program using two different methods.
Yep. So when you want to see what's actually happening, there's actually a method for that. It's a little bit not fully known, so there's going to be Hackaday articles from me about this one. because I believe more people should know about such wonderful tools because of just how much time you can save with using such a tool. But it's there, and sometimes somebody just needs to highlight it.
How would you recommend people get started with this sort of thing? If somebody was like fascinated by what they saw on the stream and they wanted to do a logic level analysis of like a USB device or something that they have that they're curious to poking around with, like what would they need to do that, or what kind of setup would they need to get started?
There is seriously cheap logic analyzers exactly like the one I'm using, and that one is like $5 to $10 on Amazon. So that's the entry level. And this one is going to work out of the box. And there is also a way to use a PyPico with Pulse View with like the underlying framework. But for that, you need to compile Pulse View on your own. And if you have Linux, then you most likely can do it. And if you have Windows, then you'll just have to wait until PulseView and Sigrok, like the underlying backend maintainers, finally merge like PyPico support. But once they do, you're going to be able to just use a PyPico for logic analyzing, in addition to all the other wonderful things that the PyPico can already do.
That's so cool, actually. Like, because I was excited for the PyPico W. I wasn't that excited for the PyPico. I love the price point. I love the support, but like, I'm a Wi-Fi person, so I love Wi-Fi stuff, and it kind of feels limiting in some ways to not be able to use Wi-Fi. But you're saying that like you can just turn this. How expensive are they? Are they like $5?
Yeah, like $3.
Okay,
And already
$3.
you can use PyPico as a USB UART adapter, as a USB JTAG adapter, as a USB to I2C adapter, and a USB to CAN adapter, I believe even, and a few others. So actually, a PyPico is a small tool in disguise, like a small
Huh.
electronics tool. Yeah.
That's fantastic. It would be cool to maybe do some like a demo of that sometime, because frankly, like I've never used such an inexpensive microcontroller for such a useful, just incredibly useful function for just hardware development. Like I feel like it,
Yeah.
yeah, of course there's tools on Amazon, but like a real hardware hacker is going to want like a $3 tool that they can burn multiple times by accident, and then just get a new one for like an ultra low cost. Of course, like don't make it too hard. If you just want to do logic level analysis, then like don't wear yourself out trying to do it all custom. But if you're a hacker and you want to build your own, it's really nice if it has good community support, especially if it's Linux based and like open source and all that.
Yep.
Cool. All right. So for anybody who's interested, I'll put the link up to PulseView as well. It's by Sigrok, Sigrok.
Yeah.
Okay. Cool.
That's the backend. Let's switch back to the normal screen.
Yeah. There we go. All right, we're back. So
Yep.
I have never tried this before, but now I really want to because it looks so cool.
It's a full-on open source project with a lot of aspects. There is quite a bit of hardware supported, though most of it's professional. But the $10 logic analyzer is truly like a breakthrough in that it gets the logic analysis features to any hobbyist's toolkit if they just know what specifically what to buy and what to open.
That's
And
really
yeah.
cool. That's really, really cool. So one way I can immediately think that this would be useful is like when I'm working with CircuitPython, it allows me to do HID stuff, but on a very high level. So if I want to see like the actual way that, when I specify that I want my CircuitPython device to act as like a mouse or a keyboard or like some other like MIDI device or something, I can actually go and look at what's being sent over the wire when it's plugged in or restarted and find out like, exactly how it's really identifying itself.
There is a limitation for that. You can't do that usually in software on your host, and the logic analyzer is not quite fast enough for USB communications, sadly. So that's kind of where the logic analyzer, because it has to capture signals at a pretty high rate, and the USB rates are way too fast for typical logic analyzers that are not way too expensive to catch up. So that's not exactly something you can do. But if your microcontroller is talking to an SPI screen, for instance, and there is some weird problem with that, or if it's talking to an I2C device that, oh yeah, something I remember is that me and my friend were developing a medical device that was like the prototype was powered by MicroPython, and there was a problem in that where when you write spi.write in MicroPython, you write the piece of code that says spi.write. That's a function, and there's two different arguments that you can pass to that function. So you can tell it to write, and you pass it an integer, and you would think that it just sends that integer over the wire. So it just pulses up and down, saying, and it all comes into like 73, let's say, like we've just seen in the pulse view window when it came to UART, like it's also up and down pulses. But it didn't actually do that. And instead, when you pass 73 to the write function, what it does is it sends 73 empty bytes. So it sends 0 73 times. And of course, you know that if you read the documentation, but you usually don't expect that to be the problem. Because usually when you say you write code that says print, and it prints, like you say, to print 73. It prints 73. So we expected the write function to basically, like subconsciously, we expected that to do the same. And we were debugging that, and of course, well, we didn't think about checking the documentation for that function, but we decided to plug a logic analyzer in, and that's where the problem became apparent, because then we immediately saw that it's sending 73 times the 0 byte instead. And then we checked, and then we found out that we made the wrong assumption. And otherwise, that debugging session could have lasted for hours. But with the logic analyzer, we just went and we plugged it in, and we saw what actually happened on the wire. And sometimes it's like you have a UART connection, and nothing is coming back, and you're sending data, and nothing is coming back. Or maybe you're expecting data, and the data is not coming. And in the code, you see nothing, but when you connect the logic analyzer in, you can, for example, tell that it's a different baud rate. So your USB UART adapter does not recognize this baud rate, but your logic analyzer will capture it anyway. The baud rate from the shape, like the timing of the signal, of the raw signal that you see. And the USB UART, you have to tell the baud rate beforehand. They don't auto-adjust. They expect you to already know the parameters. And that's where a logic analyzer is indispensable, absolutely.
Okay, so for me, then that would mean if I'm adding a sensor, if I'm like making assumptions about the way two devices are communicating, this is the way to test those assumptions and make sure that nothing weird is going on that I didn't account for. Especially if I don't have time to go through all the documentation for every function that I'm using, and I'm just trying to make it work. So yeah, that seems like a lot of time that would have been wasted otherwise, and a lot of like very specific documentation you have had to read to figure out the issue. So James has reported, this isn't going to be a long enough live. We might need to add a part 2. Would you like to come back and talk about some more electronic stuff another time?
Sure, absolutely.
Cool,
bring better demos as well. Demos are wonderful.
Hey, no, that demo was great. Like for somebody who's been curious about the way that like hardware people figure out these sorts of problems, and also for knowing that I can use a Raspberry Pi Pico like that. Like people love their Raspberry Pi Picos, but they're constantly looking for ways to use them in a practical fashion. So the fact that there are projects out there that allow you to do it, like that was more than worth it today. So thank you very much for that. And of course, also, if people want to stay up with you, I have your link tree up right now. But obviously, like, I feel like people who are interested in what you have to say would want to follow your Twitter, maybe want to follow like your Hackaday articles and stuff. So the link tree is, as far as I'm aware, the approved way to dig into all the fun stuff that you're working on.
Yep.
Yeah, and of course, if you want to support our fantastic guest today, you can always go on Tindy and purchase like one of those like USB. What were they called? The whatever friends?
Yeah, alt mode friend.
Atmo
That's a
friends.
technical term for different features that you can pull out of a USB-C device.
Yeah. So if you wanna support our friend today, you can always do that. Thank you, Arya, very much for coming on. And per usual, I just want to give a shout out to our sponsor who makes all this possible, Varonis. If you want to check out what we have for free coming up, you can go to varonis.com/Kody. That's Kody, and you'll find our DSPM event coming up, which is data security posture management. It goes all through how companies posture themselves to make sure that if they have a breach, that it is not that big of a deal and they don't lose everything. So it's going to be a really interesting perspective from some great experts. You can check it out at varonis.com/Kody. And of course, you can follow Arya on Linktree/Crimer, right?
Yep.
Cool. All right. So if you have follow-up questions and you want Arya to answer them on our next stream, you can either leave them on the channel, which, by the way, please make sure to subscribe. And you can also go on our Discord community. So I shouted it out in the chat numerous times. That link will expire eventually. We'll put up a more permanent one. But we are launching our Discord community. So in our Discord community, you will notice that there is a section that is specifically dedicated. Oh, hello. That is specifically dedicated to the live Q&A. This is like a form style one. You can go ahead and make a new question and we will respond to it. And the goal is like maybe we'll have some responses either pinned or also people in our community can help answer it until we get there. So by the time we get to it next week, maybe 3 other people have already responded. We'll be able to have some perspectives to discuss. So I love how you guys answer each other's questions in the chat. That's fantastic. And we love you for that. This is a way of just continuing the conversation because often we get, right stirred up. We're having a lot of great conversations and then we run out of time. So go ahead, join the Discord server. We will all be there to hopefully answer your questions. And you can catch me again live on Friday when we'll be doing the news stream, which is going to be a lot because there were some things I was going to mention today and I didn't even get really a chance to, aside from a very happy birthday to our friend Tim, who's been on the Nullbyte channel before. We made him a birthday friend to walk down and find in the morning, and he was very surprised. So congratulations to Tim on surviving another year on this earth. It's great to have our content creators be able to be greeted with the Queen Mother waiting for them in their living room unexpectedly. And yeah, there's lots of stuff to talk about. Using AI to scam people who have Twitter Blue, updates to the Flipper platform. There's also this viral TikTok video that got taken down exactly 2 years ago. Well, not exactly, but close to 2 years ago when somebody called and tried to get me fired for posting about vulnerabilities in a Dunkin' Donuts. Don't mess with the Dunkin' Donuts people is what I learned. Some cool stuff about using AirTags as a like C2 server. And even oh yeah, and then my attempts to make a Shrek cake with AI, which did not go well. Shrekky. Anyway, that's all we have for this week. Thank you to everybody who has joined us and asked excellent questions. Again, jump on the Discord server if you want to keep in touch, ask your questions for next week, and we will see you next time. Thank you.
Thank you.